Okay, next let's look at one-sided and two-sided Laplace transform. A one-sided or unilateral function is 0 for negative time. Alright, that is for t less than 0. Okay, where 0 denotes the time just before 0. So the Laplace transform of function xt is this, right? You can see that for one-sided, right? So one-sided, we can see that anything below 0 is just 0. Alright, so the only xs only exists from 0 to infinity for the positive right hand side, right? So only exists here. So this is 0, so it only exists this side. That is one-sided. For two-sided, Laplace transforms allow time functions to be non-zero for negative time. Means that for negative time it is not 0, right? Not 0, so it exists, alright, for negative time and also for positive time. So for that, when we do Laplace transformation, we have to consider negative time, meaning that the signals which exist before t equals 0. Alright. However, in this topic, we will only cover for one-sided Laplace transform. So let's look at Laplace transform of simple time function. So we have one example here, right? Determine the Laplace transform of each of the following functions. For the first one is ut. This is a signal, ut signal, which is a ut, right? Means that the amplitude is 1. Okay, that exists from 0 until infinity, right? So if it is ut, 2 ut, then 2 here, right? So never mind, let's do Laplace transformation of signal ut. Take note, this is time domain. So how the signal represented in frequency domain. So to do Laplace transformation of ut, right? If you recall in the previous video, we have to use this equation, right? We have to use this equation. So in this case, what is ft? Ft is ut or just 1, right? Just 1. So ft actually, or ft is actually 1 ut, right? Because this ut here represents from 0 to infinity. Alright, so in this case, this ft is 1, right? And then we have to multiply ft with exponential negative st, right? And then from here we integrate this, we will get 1 e negative st, and then this negative s, we bring it down s, alright, and then we integrate from 0 to infinity, right? And then we replace t with infinity, okay? And then because this is minus, this is plus, right? Minus and minus will give us plus, and then here is 1 because of negative s 0, right? We replace t with 0, so we will get 1. this case negative s infinity, so equals to 0, right? So in this case, the Laplace transformation of ut or Laplace transformation of 1 is 1 over s, right? So that is how we use this equation. Now let's look at the second example. We have exponential negative a t, right? How to perform Laplace transformation of exponential negative a t. So you can see here negative negative a t times ut means that the exponential function only appears from 0 to infinity, right? So meaning that we will integrate from 0 to infinity, right? So same thing, ft here is actually exponential negative at, and then multiply with exponential negative st, right? So we have two products of exponential. So what we can get here is actually we can factorize here to exponential s plus a t. Okay, try to factorize here, and then we can negative s plus a t and then negative s plus a, right? We integrate, then we will get this, and then we can replace t with infinity, which we will get 0, and then replace t with 0, which we will get 1, right? Then finally we will get 1 over s plus a. Alright, remember, infinity, replace t with infinity, we will get 0. Okay, 0 minus this, which is now negative 1, right? Because of 0, then we will get 1 plus over s plus a. Alright, alright, so next, determine the Laplace transform of ft sine omega t ut. So this is quite slightly complicated, right? So same thing, since we have ut here, means that we integrate from 0 to infinity, because of this signal ft only exists from 0 to infinity. So here we have replaced ft with sine omega t. Alright, so this is what we need to solve now, right? So in order to solve this, we have to change this into exponential form, which is actually which we can refer to Euler's formula, right? Which is sine x equals to exponential ix minus exponential negative ix over 2i, right? So we can transform this into exponential form, alright? So which we will get this, alright? And then we can bring it outside, right? Constant value, this is constant value, we can take it outside, and then from here, from this component, we can try to factorize, same as we did before. So we come up with this, which is the final result after we integrate and replace with 0 and infinity, right? Try to solve, you will get this, and then from this you can solve to get omega over s squared plus omega squared, Alright, so basically if you are given any ft, right, you will need to use, if we use this equation, we can solve the Laplace transformation to get fs. Right, so same thing here, right? So we represent or convert cos omega t, right, into exponential exponential form, right? Exponential form here. Then we can replace, we can solve this equation, alright, because this is in exponential form. So to do that, to solve this, we have to replace or transform ft, which is cos omega t, into exponential form as well, so that when these two are in exponential form, we can factorize and solve the integration. Right, so basically the solution is quite straightforward. Okay, you just need to change it first into exponential form, then you can solve, then finally this is the results.